Hello guys, welcome to the revision. This is the Science paper 2 revision, the paper that was written on 7th August 2018, Examinations Council of Zambia, Examination for General Certificate of Education Ordinary Level GCE. So this is ECZ, this is the GCE paper that was written in 2018 Science paper 2. Okay. So I want this to revise this paper so that guys, as you write the exam, you must have some ideas on how to answer certain questions in the exam. All right, so let's go straight into the revision. All right, so section A, answer all the questions, use the answer grid provided. Okay, question 1 reads, which of the following branches of chemistry involves the study of the chemical nature of living matter? Okay, so they want us to actually choose from these the branch of chemistry which involves the study of the chemical nature of living matter. Okay, so there are about 5 branches of chemistry that are studied at the secondary level in Zambia. We have biochemistry, inorganic chemistry, then we have physical chemistry, then we have analytical chemistry, inorganic chemistry. So there are about the 5. So the branch of chemistry which involves the study of chemical nature of living matter or living things is actually biochemistry, guys. Okay, so let's go to question 2. Let's squeeze it here. Question 2 reads, the diagram below shows the chromatogram for a dye. So the diagram below shows the chromatogram for a dye. Okay, so what is a chromatogram? A chromatogram is the appearance of the separated dyes on a filter paper. So the appearance of the separated mixtures on a filter paper, that's filter paper with the separated colors, is what we call chromatogram, and this happens in chromatography. Okay. So chromatography actually is the method used to separate a mixture of 2 or more soluble substances such as the colored substances or dyes. Okay, so they're saying, what is the RF value for the dye? What is the RF value for the dye? So RF stands for retention factor. So don't go in an exam without knowing this. RF stands for retention factor. So retention factor is found by distance moved by solute over distance moved by solvent. Okay, so in paper chromatograph, what is the solute? The solute is the dye that is being separated. Like this dye, they had to put it on a filter paper here on this point. Then what they did next was to dip this filter paper in solvent, so that the solvent, when it is absorbed by the filter paper, it dissolves this dye and carrying it in the process separating it. Okay, so except that this diagram, I don't know why it's like this, because this was actually typed a question by these guys who sell past paper questions. So I didn't see the original paper how it was, because the arrangement, the way it is actually wrong. You cannot dip the filter paper into the solvent like this. The solvent will actually fall into the water, dissolve into the water, and won't be separated. So it's supposed to be above, like somewhere here. Okay, but nevertheless, we are going to answer this question. So this, when it was put here, the solvent got into the filter paper, carrying it along, and it separated into that, where they're saying final position of the dye. And this line here called the solvent front is the distance moved by the solvent as it travels through the filter paper, carrying this solute here. Okay, so that is it. So when carrying the answering or calculating the retention factor, you get distance moved by the solute, which is from here or somewhere here where it was supposed to be this one, up to where it is here. So from somewhere here up to somewhere here, which could have been, let's say 5. Let me just see how this could have been. So let me just say see if we could have picked it from here up to there, which is 15, then from here up to there, which is 25. So let's say 15 divided by 25, 15 divided by 25, 0.6. Okay, so the answer that we are going to find will be very close. So in this case, RF will say RF is equal to distance moved by solute, will say from where it is to where it ended here, which is the 20 mark. So say 20 divided by distance moved by solvent from here to there, which is the 30. So we divide 20 divided by 30, which gives us 0.7. Okay, so the answer is A. Okay, so guys, let me give you a quick reminder, guys. So guys, remember on Tuesday there will be science paper 1 examination for you GCE people. So guys, I want to advise you that we have a package for revision for past papers from 2015, paper 1 and 2 up to 2021. So for a quick revision for some of you that need to go there with an open mind, confidence, going to get proper results in the exam, please don't go there without revising. Request this package at only 60 kwacha. Okay, so you can even team up with your friend, you combine, you get a 60 kwacha, you send it to me on the number that is appearing on the screen. Then you send me a screenshot on WhatsApp. Then I give you the package of those revisions so that you know how to answer most of the questions. All right, so if you love yourself, you value your education, please don't stinge yourself this opportunity for just 60 kwacha, because the results that you are going to get after you have made it in science is going to be more important than the 60 kwacha that you are going to pay. All right, so you value your education, put something in it. So because these videos, they're going to make your revision very quick, and it is going to make your learning curve very quick. Okay, so that's how it will help you than you searching the questions, how studying a lot of notes. It will take time for you to do a quick revision, but with these revision packages, it will come with a full organic lesson, also a full radioactivity lesson, and also lesson on electricity, then also lesson on how to write chemical equation, how to balance chemical equation, more concept. So this is the package which is coming with this 60 kwacha only, guys. The deal is done. All right, so if you are enjoying this video, you have learned something, give it a like. Please remember to share. Some of you are seeing this video for the first time because someone never shared. Someone said, no sir, I just saw this for the first time. I didn't know you were doing tuitions online. I was doing, because people don't share. Please share. And thank you very much for you guys subscribers. For you people who watch without subscribing, please, I need you to subscribe to this channel. Support education channel just as you support music channels. We don't know why education channels are not supported when education is also important. Please support this. Let's say 2,000 people subscribe to this channel. We make history. The only person that I know that made history in this world, to whose channel was subscribed without videos, is Music Alfonso, aka Muzo. He's the only person I know that made history on his channel where people subscribed without videos, including me. I did subscribe. So let's also make history in a day. Everyone that watches subscribes, so we see history in the education channel. All right, thank you very much for subscribing, thank you very much for liking, thank you very much for sharing this video. Okay, so let's go straight into the revision. Okay, so this is question 3. Compounds X and Y are both miscible and soluble in water. Compounds X and Y are both miscible and soluble in water. Compound X boils at 90 degrees Celsius and compound Y boils at 110 degrees Celsius. what is the best method that can be used to separate them. Okay, so guys, you need to understand what miscible liquids are. Okay, so these miscible liquids here are liquids that when they are mixed, they mix uniformly. Like when you get water and alcohol, when you mix them, these two mix uniformly such that you cannot distinguish them from each other. So such liquids mix uniformly. Now they're saying they have a boiling point as follows. Compound X boils at 90 degrees Celsius and compound Y boils at 110 degrees Celsius. Then they're saying, what is the best method that can be used to separate them? So the best method for separating these miscible liquids that boils at different temperature, the method that we use is the fractional distillation, guys. Okay, so the method is the fractional distillation. Okay, so let's continue moving. So let me just move the cursor here, which is actually stucky. Okay, so let's go to another question. Question 4 says, the boiling points of some elements are given below. The boiling points of some elements are given below. Element, then boiling point. We have nitrogen, boiling point negative 196 degrees Celsius. Argon, boiling point negative 186 degrees Celsius. Oxygen, boiling point negative 183 degrees Celsius. Then they say, they're saying a mixture of the above gases at negative 200 degrees Celsius is allowed to warm up gradually by 16 degrees Celsius. Which of the three gases will be in a liquid state with the change in temperature? Okay, so they're saying this now a mixture of these gases is now at negative 200 degrees Celsius is allowed to warm up gradually by what? By 16 degrees Celsius. Then they're saying which of the three gases will be in a liquid state with the change in temperature. So they want these liquids for us to state which one of these gases will be in a liquid state by this change in temperature when they are all starting from negative 200 degrees Celsius. Okay, so what you should understand is that if they are all starting from negative 200 degrees Celsius, okay, then you warm by 16 degrees Celsius. Okay, so when we add this and this, we need to know now the temperature of these two. Okay, so we'll say 200 negative plus 16 degrees Celsius. What are we having? Negative what? Negative 184 degrees Celsius. So that's how the temperature will change from here to there. So now they're asking that, sorry guys, forgive me, I have this flu. So which of the three gases will be in a liquid state with the change in temperature? So from this temperature will be this one. Which one will be in a liquid state? So we'll start analyzing one by one. Nitrogen boils at negative 196 degrees Celsius. So meaning at this temperature, nitrogen will be changing from liquid to gas. That is where it changes from liquid to gas. In case if it has been liquefied, it has been made into liquid. If you wanted to boil it back into liquid at negative 196 degrees Celsius, it has to boil back into the gas. Now, when you compare this and this, if you understand mathematics very well, this negative 184 degrees Celsius is bigger than negative 196 degrees Celsius. So if you understand, the point is, if you understand mathematics, you must understand this, because right now it will be very difficult to make you understand this. Okay, so meaning that when you reach negative 196 6 degrees Celsius, this guy should start changing into gas. So before it reaches to 184 degrees Celsius, this temperature. But since they're saying now they increased it to this, so by the time the temperature was somewhere here, because when they were here, all of them, they were in liquid because these temperatures are below this. So when the temperature increased by this, the moment the temperature started increasing from negative 200 degrees Celsius, it reached this. Before it reached this one would have turned into gas. Then this one, the boiling point is negative 186 degrees Celsius. So also when you compare this one and this one, this is less. So as you move from here, you find that it reached quickly this one before you reach this one. So from 200 you go to that before you reach this one. So this one is reached area before you reach this one. So by the time this one reaches here, it will be boiled, it will boil into gas. Before it reaches here, it is already in gas. So this one also goes into gas. Then when you come to oxygen, negative 183 degrees Celsius, and this, you discover that this one is larger than this. Meaning as you start increasing this by this, then this one is going to move to 184. So 184 degrees Celsius, when you compare with this one, it is actually small. This one, when it reaches 184, you would have not yet reached 183 degrees Celsius. So this guy will still be in liquid. So when they say which of the three gases will be in a liquid state with the change in temperature, so it is actually a C. So you see the analysis which goes on in answering some of these questions. Okay, so let's move to the other question. So question 5 says, how many elements and atoms are there in a molecule of ammonium phosphate, which is open brackets NH4 close brackets 3PO4? Okay, so they want us to know the number of elements, how many elements and atoms are in this molecule, ammonium phosphate. So okay, so elements, these we have nitrogen. So in terms of elements here, I can see that we have nitrogen 1, hydrogen 2, phosphorus 3, then oxygen 4. So we have 4 elements. Now in terms of atoms, total atoms, how many are they? So you add like nitrogen, how many are there? Nitrogen, so let's say nitrogen atoms, how many are there? So nitrogen, because of these 3 outside, it's being shared by these inside. So nitrogen meaning there are 3 atoms. Then you come to hydrogen here, so you say hydrogen. Okay, so how many are there? Because of these 4 next to hydrogen, so there are 4 hydrogen atoms. And because of these 3, you multiply 4 by 3, so you have 12 atoms of hydrogen. Then here phosphorus, you just have 1. Then for oxygen, we have 4 next to oxygen, meaning oxygen we have 4. Then we are going to add these atoms to know the total number of atoms in here. So say 3 plus 12, which is 15, plus 1, 16, plus 1, which would plus 4, I mean, which would be 20. So in terms of atoms, we have how many? 20. Okay, so when they say how many elements and atoms are there in a molecule of ammonium phosphate, so we come A, number of elements 20, not true. Elements are supposed to be 4. Then here number of elements here 11, not true. They're supposed to be 4. Here carbon, I mean C, number of elements, how many? 4. Good. Here number of atoms 11, not true. Atoms are supposed to be 20. Here D, number of elements 4, yes 4. Number of atoms 20, yes 20. So the answer is D. 6. The table below lists the data obtained in titration. Okay, so this table below now is listing the data that is obtained in titration. Okay, so titration is a method that is used to determine an unknown concentration of a solution. So how is it used? Especially it is used to to determine the concentration either of an acid or a base. So if you get an acid with a known concentration, you react it with a solution of known volume but an unknown concentration, then titration is going to help you through the calculations to know that concentration of an unknown solution, or to know unknown concentration of a solution. So now what do they do? The correct values. So like maybe let's say you want to know the concentration of hydrochloric acid, so you should get hydrochloric acid, its volume in a pipette. Then you get also the acid whose concentration is known. So let's say the acid is the one you want to know its concentration. Okay, you pipette it in a pipette, then you get sodium hydroxide, you put in a burette, so you start measuring. Now in this case, maybe they were measuring the volume of the acid against the volume of a base. So you do it several times. When they say trial, these are the number of times they did the titration. So titration number 1, the volume that went for the acid was 21.9. Titration number 2, 22.8. Titration number 3, 22.9. Titration number 4, 23.0. Then they say which reading A, B, C, or D on the table should not be included to compute the average value of the acid used in the titration. So they want us to actually state or answer the volume or the reading which should not be included in the computing of the average volume of the acid used. Okay, so these are the trials which they did, like I've said. So now let's see. They got 21.9, 22.8, 22.9, 23. So the one that must be excluded or must not be included should be the one that is very far from other values. Okay, so let's say we round these to to do two significant figures. So if we round this to two significant figures, it will be 2. Then we'll stand here, we check this number is greater than 5, we get a 1, we add to this one, we get 22. Then we come to this one also, we write 2, we look at this one, we check the next number is greater than 5, we get 1, we add to this, we get 3. We come to this one, 22, we write 2, then we look at 2, next to 2 is 9, we get a 1, we add to this one, 3. Then we get this one, 2, we look at 3, next to 3 is 0. Can we get the 1 from 0? Nothing, so it will be just 2, 3. So when you look at these numbers, the one which is far from others is this one. So the one that we must not include is actually this one, A. Okay, so let's go to question 7. Element X has 2 natural isotopes. Isotope with a relative atomic mass number of 10 has a relative abundance of 20%, while the other isotope with a relative or with a mass number of 11 has a relative abundance of 80%. Find the mass number of element X. Okay, so when you are talking of isotopes, isotopes are atoms of the same element that have the same proton or atomic number but different mass number or neutron number. So generally, most of the elements known on Earth exist in isotopic form, meaning they exist in more than one form. Like we have carbon 12, carbon 13, carbon 14. So these are isotopes of carbon. But on the periodic table, we don't find carbon 13, we don't find carbon 14, we only find carbon 12. That is because there was a calculation to come up with a relative atomic mass that must be recorded on the periodic table, and that's what they want in this question. So you're going to know how to do it. So they're saying we have element X has 2 natural isotopes. The isotope with a relative mass number of 10 has a relative abundance of 20%. So there is one isotope in this one which has a mass number of this and abundance of that. while the other isotope with relative, so there's another one with relative mass of 11 and has a relative abundance of this. So its abundance is this. That's how much this one is there, and that's how much this one is in there. When they say now, find the mass number of element X, so the one that actually they can even include on the periodic table. So mass number, which is supposed to be relative atomic mass, is supposed to be like this. AR, relative atomic mass, must be equal to the summation. Okay, so this one came equal like this one. Supposed to be here. Equal to summation, meaning the sum. Summation meaning the sum of the atomic mass times abundance of those isotopes. So relative atomic mass is the sum of the mass number of the isotope times the abundance. So what this means is this. In this element, which exists in these two forms of isotope, so you need to get the mass number, this one, times the abundance, then plus another one. That's why we are saying summation. Depending on how many isotopes are there, you add this times this plus this 11 times this, because here we have 2. So we are going to say, okay, equals, so get 10 of this guy times 20, then plus 11 of the other guy times 80. That's how we do it. Then we say equals. Then what we are going to do, convert these percentages into numbers. So we divide by, we say 10 times 20, then divided by 100 to convert from percentages into numbers. Then plus 11 times 80 divided by 100. Okay, so what you are going to say is to say 10 times 20, which is 200, divided by 100, which is 2, then plus, then you say 11 times 80, then you divided by 100, which will be 8.8. Then what you are going to do is to add 2 plus 8.8, which will give you 10.8. So as our relative atomic mass, so the answer is D. So let's move to question 8. So question 8 says, aqueous silver nitrate reacts with the aqueous sodium chloride according to the equation below. Aqueous silver chloride reacts with the aqueous sodium chloride according to the equation below. So we have aqueous silver chloride reacting with the sodium chloride, forming silver chloride plus sodium nitrate. Then here we have energy change negative 65.7 kilojoules per mole. Then they're saying which one of the following statements above, which one of the following statements about the above equation is not correct. Okay, so let's see. Number 1, A, they're saying 1 mole of silver nitrate produces 1 mole of silver chloride. Okay, when we check here, this is actually 1 mole because there's no number here, and here also we have silver chloride 1 mole because there's no number here. So it's true. This one is a true one. It's not incorrect, because the question is saying which of the following statements about the above equation is not correct. But this one is not correct. It's correct, so it's not the answer. We are looking for the one not correct. Then B, the total energy of the product is greater than that of the reactants. Okay, this one seems quite tricky. When you check here, energy change here, if it is negative, then it means that there was a reduction of energy by negative 65.7. So if this reaction involves a reduction, energy change is negative, meaning negative 65.7 has been reduced from this. It has been lost. Okay, so if this amount of energy has been lost, then it means that the reactants, products, have got less energy as compared to reactants. So when they say total energy of the products is greater than that of the reactants, this is not true. So not correct. So this is the one which is not correct. Okay, so let's go to question 9, which says conditions under which zinc reacts with dilute hydrochloric acid to produce zinc chloride and hydrogen gas can be changed to alter the rate of the chemical reaction. So conditions under which zinc reacts with hydrochloric acid to produce zinc chloride and hydrogen gas can be changed to alter the rate of the chemical reaction. So which of the following conditions will not alter the rate of the chemical reaction? Okay, so guys, here this question is coming from the rate of chemical reaction. Rate of chemical reaction. So chemical reactions is the speed of how fast the study of how fast the reaction go. So under chemical reaction, rate of chemical reaction, we talk about the speed of chemical reactions and the factors that affect the speed, such as temperature, concentration. We talk of pressure, surface area, and also we talk of catalyst. So now, in this case, if you have zinc here reacts with dilute hydrochloric acid, zinc is in a solid state, then this dilute hydrochloric acid is in aqueous state. Okay, aqueous, which is air, and Q like this, aqueous state, meaning in solution state. So what you should understand, guys, here is this, that reactions that are in a solid state, the factors that affect them are temperature, what else? Temperature, catalyst, and also surface area. Those that are in liquid are affected by temperature, concentration, and catalyst, not surface area. So in this case now, this zinc and hydrochloric acid, if they are reacting, what can affect their reaction is concentration, surface area, temperature, catalyst. Okay. Then for reactants such that are in a gaseous state, factors that affect them are pressure, concentration, temperature, and catalyst. So pressure, concentration, catalyst, temperature. Those are not affected by concentration, because concentration is only for those in a liquid. So when they say which of the following conditions will not alter the rate of the chemical reaction, which will not affect this one? Concentration does affect, because this one is in a liquid form. Then pressure only affects those in a gaseous form. So this one is a solid, this one is aqueous. So this one will not alter or change. So the answer is B. So let's go to question 10. 10 says a student adds 4 drops each of the universal indicator to 2 test tubes containing unknown solutions. The solution in test tube 1 turns violet, while the solution in test tube 2 turns green. What are the two solutions? What are the two solutions likely to be? Okay, so we are told that a solution adds 4 drops, adds 4 drops each of the universal indicator to 2 test tubes. So the student has 2 test tubes. This is test tube 1, adds 4 drops of the indicator. Yes. Then another test tube. This is test tube 2, again adds 4. So they're saying the solution in a test tube 1 turns violet. So here it turns violet, while the solution in test tube 2 turns green. Here the solution turns green. Okay, let me do like this one. Turns green. So this one turns green. So the unknown solution in here turns violet, here green. Then they say, what are the two solutions likely to be? So the one that turns violet must be an alkali. Then the one that turns green must be neutral, like water or salt. So it must be neutral, like water or a salt, because the salt is neutral. So when we say test tube 1 sodium hydroxide, it makes sense. Sodium hydroxide is an alkali. Test tube 2 sodium chloride is a salt. Yeah, so this one makes sense. Let's see this one. So test tube 1 sodium hydroxide, no. C test tube 1 sodium hydroxide, yes. Here nitric acid. Nitric acid in test tube 2, nitric acid does not change color of green. It's not green. It must be red or yeah, purple, something like that. Yeah. So what makes it green? It should be water, and this one is neutral. So the answer should be A. So let's go to question number 11, which says study the reaction scheme below. So study the reaction scheme below. So this is the reaction where we have solution R to solution R, add a few drops of aqueous ammonia, white precipitate formed, then add excess aqueous ammonia to the white precipitate. Precipitate dissolves, giving a colorless solution. Then here the same solution, if they add a few drops of aqueous sodium hydroxide, then the white precipitate is seen. Then when they add excess sodium hydroxide to this precipitate, a precipitate dissolves, giving a colorless solution. What is the formula of the cation in solution R? Okay, so this one I even taught on my channel, qualitative analysis. So if you check in my channel qualitative analysis, you'll be able to see the video. But for those of you that are going to pay the 60 kwacha when you come, you can also ask for qualitative analysis notes so that you study, you memorize them as you go in exams, because GCE exams are tricky. They may bring a question just like that. Without you studying qualitative analysis notes, you are not going to make it in answering such questions. So an ion which is here, a cation which is here with these results here is actually D, zinc. It's the one which produces these results. Okay, so let's go to question number 12, which says halides are used to make a number of useful substances, some of which are pollutants. Halides. So halides are group 7 elements, excuse me. So halides are used to make a number of useful substances, some of which are pollutants. Which of the following substances are not pollutants? A, chlorofluorocarbons. Not true, these are pollutants. Toothpaste. Okay, so fluorine, for example, it is in group 7. It is added to toothpaste to prevent teeth decay. So if it is added to teeth, can we call it a pollutant? Not at all, because if it were a pollutant, it could have caused harm to us. So something which is not a pollutant here is actually B, toothpaste. Then 13, what result is obtained when excess aqueous ammonia is added to a solution containing copper 2 ions? What result is obtained when excess aqueous ammonia is added to a solution containing copper 2 ions? Okay, so this is also coming from qualitative analysis. So if you get excess aqueous ammonia, you add to a solution of copper 2 ions, or a solution containing copper 2 ions. What can you see? You see a blue solution is formed. So this is the answer. Okay, so let's go to question 14. Question 14 says, which of the following is a use of a metal due to its malleability? Which of the following is a use of a metal due to its malleability? Okay, so here they are talking about properties of metals and the usefulness of that property of a metal in a metal itself. So again, those that are going to pay the 60 kwacha, I said it will come with a package of notes on metals, summarized one, then also on nanometals and their uses and their production, and also I said it will come with a package on organic chemistry, complete video, radioactivity, complete video, then also on more concept, complete lessons, then also on chemical equations, okay, and also maybe bonding. So depending on the response that I'm going to have, I may also add chemical bonding on those. So guys, make your effort, pay for your education, very important. Just as you pay for shows in music, whatever way you go to, if you value your education, which is going to make change in your life, then do something as you go to write the exam. Have this package, revise, go with an open mind, confidence you answer the exam, because your life is important than the 60 kwacha. What you are going to realize after you pay is very important, because it is going to make your learning curve shorter. It is going to make your revision process shorter and quicker, and then have the knowledge that you need to answer the exam. Okay, so let's answer this question. So malleability. So the property of metals which we call malleability, they have this property of being malleable, meaning able um, to be compacted or hammered into thin sheets, and that is why metals can be made into ions. So when they say which of the following is a use of a metal due to its malleability, a conductor of electricity and heat, not true, making of metal sheets true. So the answer is B. Okay, so let's go to 11. 15 says, which of the following air pollutants is responsible for brain damage? Which of the following air pollutants is responsible for brain damage? Okay, the one which is responsible for brain damage is actually oxides of lead. So again, these are cross-cutting issues. In our current syllabus, we do not have this part which talks about these pollutants, okay? But these are cross-cutting issues. So these cross-cutting issues, they come in the exam. Issues of pollution are cross-cutting issues. So again, it will be hard for you to find these when you read, unless you read a lot of books. But if you come to the package where we'll talk of nanometals and their effect on the environment, you find this package there. Okay, so let's go to question 16. Which one of the following is a correct definition of allotropes? So here the answer is the one which causes brain damage, we said, is oxide of lead. So 16 says, which one of the following is a correct definition of allotropes? Which of the following is the correct definition of allotropes? Then we are saying they are A, different forms of an element existing in the same physical state. Correct. So allotropes are the different forms of an element existing in the same physical state. Like we have allotropes of carbon, we have diamond and graphite. These are different forms of carbon, but they both exist in the same physical state, which is the solid state. Okay, so let's go to question number 17. Question number 17 says, the following, the diagram below show different ways in which learners wanted to collect carbon dioxide during an experiment. The diagram below show different ways in which learners wanted to collect carbon dioxide during an experiment. Okay, so learners wanted to collect carbon dioxide during an experiment. Then they're saying, which of the following A, B, C, or D is the best method of collecting of the gas? Okay, so of these methods that are shown here, which one is correct? So carbon dioxide, guys, when you check on those methods that I'm going to send on those nanometer notes, you'll find that one of its property is that it is soluble in water, so it cannot be collected over water. So since it cannot be collected over water, this method cannot work, because there's some water there. And another property of carbon dioxide is that it is denser than air. So meaning if it is denser than air, its collection is by downward displacement of air, or so I mean upward displacement of air. So air is displaced upward like that. So the one, if it is like this one, it's almost correct. The gas comes like this, but since it is open like this, it can even spill over like that. So this one can't make sense unless this one can't work unless hydrogen, which is lighter, which can allow gas to go like that. But this one is the correct method. So B is the one. So let's go to question 18, which says the diagram below shows part of the structure of a polymer. So the diagram below shows part of the structure of a polymer. Okay, so polymers are large molecules that are formed when smaller units such as monomers joined together. So polymers are structures formed when many smaller units called monomers join together. Okay, so this is in the package of organic chemistry lesson I'm talking about. So now when they say which of the following is the monomer, so this one is part of a polymer. Now they want us to choose from these a monomer that was used to make this. So how do we do it? You identify a repeating unit like this one here. This is a repeating unit. It's the same one as this one. It's the same one as this one. So these repeating units, once you identify them, you get these bonds here. You bring them here. So this bond can come here. Here it will remain with nothing. Even this bond here, it can come here. It will remain with nothing. This one also, this one, and come here. So it will be carbon, hydrogen, carbon, hydrogen with a double bond here, a carbon here, hydrogen, and this C2H5 here. So you choose which one of these here qualifies to be this monomer here. So it must have 4 carbon atoms. Here 1, 2, here there are 2, 4. 1, 2, 3, 4. And a double bond. When you come here, carbon 1, 2, no. Here 1, 2, 3, no. Here 1, 2, 3, 4, yes. So it is this one. So to shed more light, guys, let me shed more light, okay? So to shed more light, when you check this carbon, it's actually this one. This double bond is this one here. These 2 hydrogen, it's this one and this one. This hydrogen, this carbon here, it's this one here. And this one hydrogen here, it's this one here. Then this group here, it's this group here attached there, which has got a no double bond. How many carbon? 1, 2. So here 2 carbon. How many hydrogen? 1, 2, 3, 4, 5. So it's that one. Okay, so this is the answer. So let's go to 19, which says crude oil is separated into fractions with different boiling points by fractional distillation. Okay, crude oil, guys, in that package of organic chemistry available. Okay, let me not talk too much about it, okay, because people may think this guy loves money. Yes, we love money, all of us. We work for money, we are going to school for money, but in this case I want also people to benefit a lot in their studies. Okay, so now in this case they're saying crude oil is separated into fractions with different boiling points by fractional distillation. Okay, in which one of the following are the fractions arranged in the correct order of increasing boiling points? Okay, so crude oil, when it is being separated into fractions, fractions are parts of the crude oil. Crude oil, that's where petrol, paraffin, diesel, and other fuel that we use in the world come from. Okay, so it starts with what we call gasoline, liquid petroleum, then petrol, then we have paraffin, diesel, bitumen, and the rest. So this one shows a correct order of increasing boiling point. So this one has less boiling point, this one high boiling point. So the correct order is A. Then 20 says which pair of organic compounds would be used to prepare the ester ethyl ethanoate. So ester ethyl ethanoate. So esters are formed from reaction of alcohols with carboxylic acids. So when you react alcohols with carboxylic acid, you form esters. Okay, so now in naming the ester, the first part of the ester, which is methyl, here comes from the ethanol, I mean the alcohol used, while the last part of the ester comes from the carboxylic acid used. So here it came from methanol, this one ethanoic acid. So when they say which pair of organic compounds would be used to prepare the ester methyl ethanoate, then it should be methane. No. Methanoic acid. Yeah, methanoic acid and ethanol. Methanoic acid and ethanol. This one comes from the alcohol, which is methanol. No, I had to put this one. No. This one is not true. This one must come from the alcohol, then this one from the acid. Okay, so this one alcohol. So the correct answer is this one, because methyl ethanoate, methyl must come from the alcohol methanol, then ethanoate from the carboxylic acid, which is the ethanoic acid. Okay, so let's go to question of section B. Section B, 45 marks. Answer all questions in this section. Write your answers in the spaces provided on the question paper. So these are the spaces where you write your answers in. So 1A says, give 2 reasons why chemistry is important in industry. Okay, so chemistry, guys, is important in industry because it is important in the extraction of metals. The knowledge that we gain from chemistry, we use it to extract metals in industry. Okay, so then number 2, in the production of PVC. PVC stands for polyvinyl chloride. In the organic stuff is there. Okay, so polyvinyl chloride. So production of polyvinyl chloride, which are plastic that we use to make pipes, like in drainage pipes. Those that you see, drainage pipes that are plastic, are actually made of PVC. So that knowledge we gain in chemistry, we use to make polymers such as the PVC. Okay, so there are so many importances of chemistry in industry. 1, in the production of cement, purification of water, uh, uh, production of fertilizer, production of uh, um, what's this, production of fuel. So there are so many, production of alcohol by fractional distillation. um, what else, purification or refinery of crude oil. So there are so many importances of chemistry in industry, but I just gave these few here. Okay, so B says, state any 2 laboratory safety rules. Again, there are so many laboratory safety rules, so we are just going to give few. 1, do not test anything in the laboratory. 2, do not eat food when in the laboratory. Okay, so let's go to question number 2. Name the method of separation used in each of the following processes. So they need us to name the method of separation used in these processes. A, to obtain liquid oxygen from liquid air. So in the nanometal notes I'm talking about, you learn how oxygen is made from liquid air. So how is it obtained? By fractional distillation. Then B, to obtain sodium chloride crystals from an aqueous, a solution of sodium chloride. This one is crystallization. C, to find out if certain food dyes are safe for human consumption, we use chromatography. Then to obtain ammonium chloride from a mixture of sand and the ammonium chloride, we use sublimation. Okay, so let's go to question 3. Question 3 says the figure below shows the magnesium ion in the ionic bonding in magnesium oxide. So the figure below shows the magnesium ion in the ionic bonding in magnesium oxide. Okay, so this is a magnesium oxide ion that we are given with these bracelets, and then we have a charge of 2 here. So when you have a charge of 2 here, it means that a positive 2 here, it means that this magnesium has lost 2 electrons that are in its outermost shell, so that it can now gain a positive charge, and this one becomes an ion altogether of magnesium. So question A says, write the ionic, no, write the atomic number of magnesium. So how do we know the atomic number? Atomic number is equal to the number of electrons and the number of protons. So in a neutral magnesium which has not lost electrons, the number of electrons is equal to proton number or atomic number. So in this case, this one, if it lost those 2 because it has this charge, so we count those 2 which it lost: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So meaning 12 electrons in a total before it lost. So that 12 electrons is equal to the atomic number. So the atomic number for magnesium is 2. 12, I mean. Then B, determine the valence of magnesium. The valence is the number of electrons that an atom loses. So since the magnesium loses 2 to have this positive charge of 2, then the valence electron of magnesium is 2. So we are going to put 2 here. Then C, write the chemical formula of the compound formed when magnesium reacts with chloride gas. So we need to write the chemical formula that is of the compound formed when magnesium chloride reacts with chlorine gas. Okay, so it will form this one, magnesium chloride, MgCl2. So in that package, guys, there's how to show how to write the chemical formula, chemical equation, weight equation, balancing equation. It's there. Sorry for continuously talking about that, because it's really content that I'm talking about. Okay, so let's go to the other question here. Okay, so this is now question D, which says state any 2 physical properties of the compound formed in C above. So this compound is an ionic compound, and the first property of ionic compound is that it's a solid at room temperature and pressure. So solid at room temperature and pressure. The next is that it has high boiling and melting point. Okay, so let's go to another question 4. 2 grams of sodium hydroxide are dissolved in 500 cubic centimeters of distilled water. 2 grams of sodium hydroxide are dissolved in 500 cubic centimeters of distilled water. The resulting solution is then added to iron 3 chloride solution. A1, write a balanced chemical equation for the reaction between sodium hydroxide and iron 3 chloride, including state symbols. Okay, so now we want to write the reaction between sodium hydroxide solution, because it was dissolved in water, with the iron 3 chloride. So this iron 3 chloride again is a solution, because I've said the solution. Okay, when they say we write the balanced chemical equation, we include the state symbols here. Include state symbols. We must indicate now the state in which it is going to be. So sodium hydroxide is a solution. It will be, the formula is NaOH aqueous, meaning it's an aqueous solution plus Then iron 3 chloride solution is also in aqueous. This is iron 3 chloride in aqueous. When these two react, um, this is going to displace iron from here to form sodium chloride aqueous, plus this ion is going to react with the hydroxide to form iron 3 uh, hydroxide. This one will be in a solid state, it will be a precipitate. Okay, so when they say we balance the equation, we'll just check here. We'll just begin by inspecting. Okay, so when you check here where um, hydrogen is concerned, now sodium here 1, here 1, correct. Oxygen here 1. When you come here, there's a 3 outside here, meaning it's a 3. So to balance it, we put a 3 in front here. So when we check hydrogen now, it's also 3 because of this 3. When we come here, it is a 3 also, so hydrogen is balanced. We shift to iron. Iron is 1, here it's also 1, but here chlorine is a 3, but here it's 1. So we add the 3 where? Here. Okay, so sodium again, when we check here, it was 3 again, and here it has it balanced. So this is balanced now. 2, write 1 visible observation from the reaction. So this reaction, when it reacts with this one, what visible observation can be made here is that a yellow brown color solution will turn into brown colorless color precipitate. So a yellow brown color solution will turn into a brown color precipitate. So like this iron 3 chloride is yellow in color because transition metals such as iron form colored compounds. So since it is yellow in color, now when it reacts with this to form this, it will change color from yellow to brown. So brown color precipitate, that's why it will be a solid. So that is the observation that will be made. Then let's go to question B, which says calculate the concentration of sodium hydroxide solution in mole per cubic decimeter. So now we calculate the concentration of sodium hydroxide. Okay, so what we are going to do is to bring the question back here where we have question 4, of which this part B is part of, where they're saying 2 grams of sodium hydroxide are dissolved in 500 cubic centimeters of distilled water. The resulting solution is then added, blah blah. So this one not included. Let's end here. 2 grams of sodium hydroxide here are dissolved in 500 cubic centimeters of distilled water. Then they say calculate the concentration of sodium hydroxide solution in mole per cubic decimeter. So you need to know concentration C is equal to number of moles over volume. So we need to know number of moles of sodium hydroxide. So number of moles again here is given by mass over molar mass. So the mass of sodium hydroxide is 2 grams. We say 2 grams over, then the molar mass is to add sodium hydroxide. The formula is like this, OH. So the molar mass is adding the relative atomic masses of this. Sodium relative atomic mass is 23, oxygen is 16, then hydrogen is 1. When you add these, the molar mass of sodium hydroxide will be 40. So here you say over 40, then you say 2 divided by 40, you get 0.05 moles. Then you say, okay, good. Now we know the number of moles is 0.05 divided by volume. So volume is this one. Now you convert it from 500 cubic centimeters into cubic decimeter. Excuse me. So how do you convert it? By dividing by 1000. So 500 divided by 1000, you get 0.5. So you say, okay, 0.05 divided by 0.5, you get 0.1. Okay, so 0.1 as your mole per cubic decimeter as the units. Okay, So now we are done with this one. So let's go to the other part of the question. A5. A says define an endothermic reaction. So an endothermic reaction is saying a reaction which gains heat from the environment. Yeah, an endothermic reaction is a reaction which gains heat from the environment. Then B, study the reaction below. Okay, we have this reaction where we have iron plus silicon, which gives us iron silicate, I think. Then no, iron plus sulfur, which gives us iron sulfide. Yeah, this is should be iron sulfur, sulfurous or sulfur, whatever. Yeah, then there's heat there. Then they explain why. Explain why the above reaction qualifies to be an endothermic reaction. Okay, we are saying because heat is added to combine reactants into products. Yeah, why? Because we are saying there's heat here, meaning heat is needed to bring reactants into products. Okay. Then C1 says state one natural process that takes place in plants that is classified as an endothermic reaction. State one natural process that takes place in plants that is classified as an endothermic reaction. Actually, this is photosynthesis. You know, photosynthesis is the process by which green plants make their own food from light energy in the process of carbon dioxide. So, since they need light energy, they absorb it. So, since they absorb, that process is an endothermic process or reaction. Okay. So, two, they are saying, write the chemical equation for your answer in C1 above. So, the chemical reaction for photosynthesis is water plus carbon dioxide in the presence of light over chlorophyll give us glucose and oxygen gas. Okay, so this is the chemical equation for photosynthesis. So let's go to another question 6, which says the graph below shows how the mass of a lump of marble chips, which is this one, calcium carbonate, immersed in a dilute hydrochloric acid varied with time. The graph below shows how the mass of a lump of marble chips immersed in a dilute hydrochloric acid varied with time. Okay, so let's start. So coming from the rate of chemical reaction again, here we are told the mass in grams on the vertical axis. Then on the horizontal axis, we are told time in minutes. So this graph actually shows that the mass here was decreasing, which is the mass of lump of marble chip. So this mass was decreasing as the marble chip was immersed in hydrochloric acid. It was reacting, and since it was reacting, finishing, changing into something else, its mass continued decreasing until this point when it stopped decreasing, meaning this point the reaction ended. Okay, so when they're saying how long after the start was the reaction complete, how long after the start was the reaction complete. So you come to, when you come here where the graph starts going flat, meaning the reaction stops. So where it goes flat, you come to time. What you find here is 2. This 2 in minutes is time, so it is 2 minutes. How long after the start was the reaction complete? 2 minutes. The reaction was complete here, 2 minutes. Then they're saying write away the equation for the reaction which takes place. Okay, the reaction between this one, marble chip or calcium with hydrochloric acid. So you say that the calcium carbonate plus hydrochloric acid gives us calcium chloride plus carbon dioxide plus water. That's a chemical with the equation. Then C, they're saying using the graph shown above, determine the amount of marble chips in excess. Okay, using this graph above, we want to determine the mass of marble chip which is in excess, or the one which did not react. So from here, since the reaction started from here, it means that the marble chip that was provided was actually 2.5 grams. Now, this whole thing here started reacting, decreasing in mass until it reached here, then it went like that, meaning what remained is 0.5. 0.5 grams did not react. Okay, so let's go to, was in excess again. Let's go to question D. Question D says calculate the volume of gas measured at room temperature and pressure produced. Okay, so they want when calcium reacts with hydrochloric acid to produce calcium chloride plus carbon dioxide plus water. You balance this equation by putting a 2 there. Then they need you to do what? To calculate the volume of carbon dioxide gas which was produced. Okay, so now for you to know the mass of carbon dioxide which was produced, you need to know the mass, the moles of carbon, and then how do you know the moles? You make a relationship between the mass of calcium carbonate which reacted to that which was formed. So you say calcium carbonate with the carbon dioxide. So in this balanced equation, you say 1 mole here of calcium is equal to 1 mole of carbon. All right. Then you need to know now how many moles of calcium are there. So you check that. In a previous graph, we have seen that calcium was at 2.5, okay, grams. Now, if what remained after the reaction was over was 0.5 grams, 0.5 grams, then meaning what reacted was actually 2 grams. So 2 grams of calcium reacted to produce this, this, and that. So now how much of this was produced? So first we need to know number of moles now of calcium in these 2 grams. Where you are going to say, okay, to find the number of moles of calcium in 2 grams, what you are going to say is to get the relative molar mass, because number of moles of calcium carbonate in there is equal to mass over molar mass. So you get the mass 2 here divided by molar mass of calcium carbonate 100 actually. So you get it divided equals 0.02. So here you are going to have 0.02 as the mass of calcium carbonate. Here you don't know how much mass it is going to be. So this is the moles I mean of calcium carbonate. Here you don't know how much it is going to be. So you are going to cross multiply, where now you say 1 times x, you get x equals to 0.02 times 1, 0.02, which will be the moles now of calcium, carbon dioxide. Now you must know that from the mole concept that you are going to check when you get that payment, you are going to know that 1 mole at room temperature and pressure, 1 mole of any gas at room temperature and pressure, it occupies the volume of 24 cubic decimeter. Now you are going to say, now this carbon dioxide, if they have produced this as the number of moles, now you say 0.01 moles, how many volume are they going to occupy? Then you cross. So you put x here. Then you say 1 times x equals, then this times that, it is going to be 0.48 as the volume of carbon dioxide produced. Then let's go to question number 6, which says below is a diagram showing part of a periodic table. The letters are not the true chemical symbol. Okay, this is part of a periodic table, and the letters A, B, C, D, E, F are not true chemical symbols. Then they're saying A, using the letters only, choose the element which one has the highest density. So for these elements provided here, the ones that have high density are the ones found in this block of transition metals from here to here. So those ones are what is C, which has high density. Then 2, we should choose the element which is used in high light intensity bulbs. So those elements which are used in lighting intensity bulbs, used in high light intensity bulbs, it should be this one, F here. F in argon, noble gases are used for making electric bulbs because they provide an inert atmosphere, they are reactive. So F. Then it choose the element which 3 forms an ion with the positive 2 charge in its halide. So those which forms positive 2 charge are those in group 2 like A here. Okay, then B, using the letter D, write a balanced chemical equation for the reaction of element D with the oxygen. Okay, so the reaction of element D with the oxygen is that this element D is in group 3, group 1, group 2, group 3. So if you get element D plus oxygen, should form you this one. So you know how to make chemical formula using what I'm talking about that video. Okay, so now you balance this one by putting a 3 here, also a 2 here, also a 2 there, 4 there. Okay, let's go to the other question 7. When excess zinc powder is added to aqueous copper 2 sulfate, the temperature of the mixture increases. When excess zinc powder is added to aqueous copper 2 sulfate, the temperature of the mixture rises. A. What type of reaction does the temperature rise suggest? So that reaction here which makes the temperature rise is an exothermic reaction. Then B, write 1, a balanced chemical equation for the reaction between zinc powder and copper 2 sulfate solution. Okay, so if you have zinc powder, zinc is a metal, plus copper 2 sulfate solution, here it will give us what? So zinc is more reactive than copper, so zinc will displace copper from this sulfate to form zinc sulfate, then copper will come out as a metal. Then 2, they're saying an ionic equation for the reaction in B. So we write an ionic equation. So an ionic equation involves cancelling this, which will be in aqueous. The video I'm talking about on chemical equation and formula, it also involves ionic equation step by step. So here now you remain with the zinc, here you remain with the copper. Sorry, I didn't put plus 2, so it will be plus 2, then equals, here you remain with the zinc again plus 2 plus copper. So this is an ionic equation. Then 2c, they're saying give one example of the type of reaction stated in A in nature. Give one example of the type of reaction stated in A in nature. So this reaction, exothermic reaction, which reaction in nature is exothermic? Is respiration. Respiration is the process by which food is produced by the process of combustion in cells. Okay, so the process by which energy is released in cells by the process of combustion. So the process by which energy is released from food in cells by the process of combustion or during combustion. Okay, so let's go into another question 9, which says global warming is a result of pollution of the environment. Global warming is a result of pollution of the environment. Then a thin layer of ozone, O3, is present high in the atmosphere. A thin layer of ozone, O3, is present high in the atmosphere, in the Earth's atmosphere. Then 1, why is the ozone layer important in terms of human health? So we're saying because it shields living organisms from harmful rays. Yeah. So without the ozone layer, guys, up there in the atmosphere, ultraviolet rays would harm us from the sun. But because of the ozone layer, it shields living organisms from harmful rays. 2, explain the dangers of depleting the ozone layer. Okay, the dangers are that it allows harmful rays to reach the earth and cause diseases. Here there's something missing, and cause diseases such as cancer. So if the ozone layer gets depleted or it gets destroyed, then more ultraviolet can reach the earth, and then because of that cancer can develop. Okay, people can die, living things. Then B, chlorofluorocarbons, CFS, I mean chlorofluorocarbon CFCS, catalyze the conversion of ozone to oxygen. Okay, they catalyze meaning they cause ozone being converted into oxygen. Then they're saying, one, write the equation for this reaction. We need the equation for this reaction where this catalyzes ozone into oxygen. So this is the equation for the reaction where we have this actually breaks into this. So when it breaks into this, maybe let me just check for the notes maybe here if I can manage to pull something from my computer. Okay. Okay, let me just search here. CFCS. Good. So quickly, scientists think that these holes have been produced by a chemical called chlorofluorocarbon CFCs. CFCs were developed as refrigerants back in the 1950s. They have also been used in air conditioning system, aerosol cans, or propellants, and in the manufacture of expanded plastics such as polystyrene. Yeah, so CFCs are very unreactive molecules. They escape into the atmosphere, um, and because of their inertness, remain without further reaction until they reach the okay, here let me push it this way. This is the ozone, the polars where the ozone has been eaten, so rays are able to penetrate on Earth. Diagram showing hole in the ozone layer over Antarctica. Okay, so they're saying they remain in the stratosphere and the ozone layer, and the ozone layer. In the stratosphere, the high energy ultraviolet radiation causes a chemical bond in the chlorofluorocarbon molecule to break and a chlorine radical to split off from the CFC molecule, for example. So this is the chlorofluorocarbon molecule, this one here. When it receives ultraviolet light up in the stratosphere, it breaks, producing one chlorine called radical. This chlorine radical is the one here which now reacts with this guy ozone to form this compound and oxygen gas. So this is the equation they were talking about, which is in here, okay, which is this one here. So when they say chlorofluorocarbons catalyze the conversion of ozone to oxygen, one, write the equation for this reaction. So this is the equation. So again, just as I said, these are cross-cutting issues which you are not going to find in any book that is written in Zambia unless you research. But because of these revisions, you are able to know. So revisions are very important. If you get that package, then you'll be good to go. So then two, they are saying suggest two ways as to how contamination of the atmosphere by CFCs can be minimized. So number one, we can reduce the use of CFCs. Then number two, replace CFCs with HCFCs, which destroy faster. So these get destroyed themselves faster, and HCFCs actually are hydrochlorofluorocarbons. Okay, so let's hear here They're saying ozone depletion and greenhouse effect become such serious problems that an international agreement known as the Montreal Protocol on substances that deplete the ozone layer was agreed in 1987. Research is now going ahead with some success to produce several alternatives to what? To CFCs. At present, better alternatives called hydrochlorocarbons, these HCFCs, have been developed. These have lower ozone depletion effects and are not effective greenhouse gases. It is believed that the so it is believed that if the agreements are adhered to, then the ozone layer will recover by 2050. So this is 2022. The ozone layer, the way it has been destroyed, according to that report, then it can recover by 2050. So this is the report I'm talking about over the Antarctica, where ozone layer has been depleted or finished by chlorofluorocarbon. So this is coming from this here. Ozone depletion. Ozone O3 is an important gas found in the stratosphere. It is important because it absorbs high energy ultraviolet radiation. If this radiation were to reach the surface of the earth, it would lead to an increase in skin cancer and other medical problems. So in 1985, large holes were discovered in the ozone layer over Antarctica, Australasia, and Europe. Okay, so scientists think that these holes have partly been produced by chemicals called chlorofluorocarbons. So these are the ozone now we are talking about that scientists are saying if they adhere to those treatment of the Montreal and then alternative use of hydrochloro carbons instead of chlorofluorocarbons, then they're saying by 2050 the ozone can now recover. Okay, so now that is the story about this thing. Now I wanted you to get updated by these cross-cutting issues. Okay, so let's go to another question section C, 20 marks. Answer any two questions from this section. Write your answers in the separate answer booklet provided. Okay, so one, they're saying sodium chloride can be prepared by titration. Okay, then A, they're saying why is it possible to prepare sodium chloride by titration? Then B, one, name the reagents that can be used to prepare sodium chloride by titration. Then two, suggest an indicator for the reaction. And then C, describe how pure dry crystals of sodium chloride can be obtained from the mixture. Then D, state one precaution that should be taken when preparing salts. Okay, so let's start answering this question right away. Okay, so A, why is it possible to prepare sodium chloride by titration? So we are saying one, because it is a soluble salt of group 1 metals. So soluble salt of group 1 metals must be just prepared by titration method. Okay, so that is it. Then two, they're saying suggest an indicator for the reaction. We are saying no here. B1 saying name reagents that can be used to prepare sodium chloride by titration. Okay, so sodium chloride can be prepared from two materials. One, a base which contains sodium, another one, an acid which contains chlorine. So an acid which contains chlorine, hydrochloric acid. A base which contains sodium is sodium hydroxide. So you prepare it from sodium hydroxide and hydrochloric acid. Then to suggest an indicator for the reaction. So we can have phenolphthalein or methyl orange or bromothiamine blue. Okay, so those are the indicators. Then C, they're saying describe how pure dry crystals of sodium chloride can be obtained from the mixture. So we are going to say that The solution containing sodium chloride is heated on an evaporating dish and using Bunsen burner as a source of heat to saturation point, and the resulting solution is crystallized by cooling in the absence of heat on a filter paper. Okay, so what is being explained here is this: if you have sodium chloride in a solution of the water, because when you get, for instance, sodium hydroxide, you react it with the hydrochloric acid, then you form sodium chloride and water. So for you to get sodium chloride, you must first heat the resulting solution on an evaporating dish using a Bunsen burner as a source of heat. Then this heating should go to saturation point. Saturation point is a point where when you heat, most of the water has evaporated and the crystals are about to form. That is saturation point. And at that point, the resulting solution is crystallized. How do you crystallize it? By cooling in the absence of heat. So you remove heat, you allow it to cool for crystals to form. Okay, then indeed they're saying state one precaution that should be taken when preparing salts. So when you are preparing salts, one precaution that must be taken is use correct of reagents, then 2, avoid contact with chemicals, 3, use protection. Okay, then let's go to another question. Question 2. The diagram below shows the apparatus used for converting glucose, which is this one here, into ethanol. This one here. Okay, this is glucose into ethanol. Let's study it. We have the beaker here, beaker full of warm water. Then we have a conical flask. In the conical flask, what is there? A mixture of glucose and other substances. Then we have a delivery tube here, test tube containing lime water. Okay, then A, they're saying what is the name of this chemical process? B, name 2 other reagents present in the mixture in the conical flask. C, state 2 necessary conditions needed for the process to take place successfully. Then D1, what is the function of the lime water? Then D2, write a balanced chemical equation for the reaction. Then E, how is the ethanol produced in the reaction separated from the reaction mixture? Then F for state 2 uses of ethanol. Okay, so let's begin by number 1 here, A. So what we are going to do here is this: what is the name of this chemical process where alcohol is collected like this? This process is called from glucose. This process is called the fermentation. Okay, so then B, they're saying name 2 other substances present in the mixture in the conical flask. So here we have mixture of glucose and other substances. Other substances that are needed there apart from glucose is water and the yeast. Okay, now let's go to the other part of the question, which is C. So let's go at C there. State 2 necessary conditions needed for the process to take place successfully. So the conditions are that temperature of around 25 to 35 degrees Celsius, and 2, the other conditions, absence of oxygen. Then D1, they're saying what is the function of lime water? We are saying to show the production of carbon dioxide. Okay, so the other part is now this one where they're saying write a balanced chemical equation for the reaction. Okay, so the equation is that if you have glucose, then it goes into tens. Here you need to use yeast as catalyst. Okay, then it goes into glucose, it goes into ethanol plus carbon dioxide. Balancing, you put a 2 here and a 2 here. The equation is balanced. Then E, how is the ethanol produced in the reaction separated from the reaction mixture? So okay, so here we are saying it is separated by fractional distillation. This involves heating the mixture of alcohol and the water, then condensing the vapor until 78 degrees Celsius is reached to collect the alcohol. Yeah, so this alcohol is collected from the mixture by what? Fractional distillation. So what does it involve? This involves heating the mix of alcohol and water, Then condensing the vapor until 78 degrees Celsius is reached to collect the alcohol. Okay, so heating the um, mixture of alcohol until 78 degrees Celsius is reached, and then condensing the vapor. Okay, this should have come here. I didn't arrange it properly. This which I've underlined should come here, somewhere here, where you say this involves heating the mixture of alcohol and water. Yeah, somewhere here, and water. Then you come to until 78 degrees Celsius is reached, then condensing the vapor to collect the alcohol. Yeah, sorry guys for this winding of English. It never came out properly at that time. Then state two uses of ethanol. One, ethanol is used as a solvent, fuel, or to make esters. So there are many. It also it is used as a beverage when people are drinking alcohol, sanitizer, and so forth and so on. So let's go to the last question, which is 3. Potassium chlorate decomposes when heated according to the equation below. So this is potassium chlorate. When heated, decomposes into potassium chloride and oxygen. Then 1. Balance the equation above. Then B. Calculate the volume of oxygen gas evolved measured at RTP when 0.01 mole of potassium chlorate is decomposed. Then B. Magnesium oxide acts as a catalyst for the above reaction. 0.5 grams of magnesium oxide was used in this experiment. Then B, 1, what mass of the catalyst would remain at the end of the reaction? Then 2, explain what a catalyst does in order to increase the rate of chemical of the reaction. Then 3, will there be more or less oxygen produced when the catalyst is used? Explain your answer. Okay, D, describe the chemical test for oxygen. Okay, let's start answering right away. Okay, so they're saying A, balance the chemical equation. So it will be easy. We'll say, we'll write the way it is, then it gives this one, then it gives that one. Then we'll put a 3 here, then we'll put a 2 there, then a 2 here, balanced. Okay, then B, calculate the volume of oxygen gas evolved measured at RTP when 0.01 mole of potassium chlorate is decomposed. Okay, so here we're saying in this balanced equation, like some of you guys, my learners in the group, you said, sir, how do you use those coefficients in a chemical reaction? Sometimes they are used, sometimes they are not used. This is a situation in which they are used. So I hope you are watching so that you can know now. So here you have this, you have how many moles. They want how many moles of oxygen. They want the gas, the volume of oxygen which was formed when 0.1 mole of potassium chlorate is decomposed. So this one, when it is composed, how much oxygen is produced? So here is simple. So what you are going to do is you are going to say, you get the mole ratio. You say 2 is to 3 of this. Now, how about if you are given this 0.1, how much moles of this oxygen will produce? You don't know. So you cross multiply. Then you say 2 times x to x equals, then 0.01 times 3 is 0.03, divided by 2, divided by 2, this one cancels, x is equal to 0.03 divided by 2, you get 0.015 moles. So now you know the moles. Now you go to RTP. When they say measured at RTP, you say 1 mole produces the volume of 24. That is the standard. Check on the periodic table. Then if you say, now how about these 0.015 moles of oxygen, how many volume? So you cross again, you say 1 times x, because 0.015 times 24, it will give you 0.036 cubic centimeters as the volume. So you are going to say the volume of oxygen gas evolved is 0.36 cubic decimeter. Okay, so now let's go to the other part of the question, which is question C. So question C says manganese 4 oxide acts as a catalyst for the above reaction. 0.5 grams of manganese 4 oxide was used in this experiment. Then what mass of the catalyst would remain at the end of the experiment? Okay, so if they have used this as manganese, the mass remains the same because a catalyst does not get used up in a chemical reaction. It just speeds the chemical reaction. So what will remain is just still 0.5 grams. Okay. Then two, they're saying explain what a catalyst does in order to increase the rate of a reaction. So you say it speeds up the rate of a chemical reaction by lowering the activation energy needed for the reaction to start, and it remains unchanged at the end of the reaction. So what it means is a catalyst, guys, how does it speed up the chemical reaction? It lowers the activation energy. For instance, if this is the reaction progress and this is the energy needed here, energy, if reactants are at this energy level, they need to go to products maybe here. So there's a barrier which is there for them to climb to produce products. Okay, so this one are reactants, this one are products. So for reactants to form products, they need to overcome this one we call the activation energy barrier. So a catalyst, what it does, it lowers this activation energy barrier to this so that products can move properly, reactants can move properly into products. So that's what the catalyst does. That's why we're saying it speeds up the rate of a chemical reaction by lowering the activation energy needed for the reactant for the reaction to start, and it remains unchanged at the end of a reaction. So a catalyst remains unchanged at the end of a reaction. Okay, so let's go to 3, where they're saying, will there be more or less oxygen produced when the catalyst is used? We are saying there will be the same amount of oxygen produced because the catalyst only changes the rate of the chemical reaction. Yeah, so a catalyst is not going to make the volume increase or reduce, but it is not only going to make the reaction go faster. So there will be the same amount of oxygen produced because the catalyst only changes the rate of the chemical reaction. Okay, let's go to the other question, which is D, which says describe the chemical test for oxygen gas. So we are going to say the chemical test for oxygen gas is that it rewrites a growing splint introduced into a test tube containing oxygen gas. Okay, so that is it, guys. Once again, thank you for watching. If you enjoyed this video, give it a like. If you have downloaded it, please go back to my channel, give it a like, subscribe if you haven't subscribed. Please, please, please subscribe. It doesn't cost you anything. Just your hand, click on the red subscribe button, turn on the notification for you to receive updates. Support this education channel for our country, Zambia. Okay, so for those of you for revision, guys, the number is on the screen. Let me receive you, pay the 60 kwacha and the packages that are coming with it. You move in your life, in your future, just as you want it to be. Guys, for now, thank you for watching. Bye, and please, I wish you all the best in the exam. I wish God's blessings help you to remember everything that you have studied so that you make it in life. For now, bye, and please, peace.